So now we are going to move along and start talking about some restoration work. We're going to start it off with Dan and Mary, who are going to be discussing the degraded lands mapping technique that we came up with. And I've already introduced both of them. I could sing their praises for longer, but for time, I'm not going to do that.
Okay. So thank you, Tiffany. I'm not on mute, right?
Okay.
Okay, thank you. So Dan and I are excited to share with you this project. This is a methodology that we've been developing that uses citizen scientists, it uses Google Earth and other remote satellite imagery to identify degraded areas in the Sonoran Desert. The example in this presentation is the preserve, but we have moved on to apply this methodology to 2 of the regional parks. And so both Dan and Helen developed this method, and I've been working closely with them on this project since I've began my journey with the conservancy. So as an introduction, we've learned a lot about restoration and why we want to restore lands. I kind of think of a degraded site as a piece of property that's like on low battery. So it's an area that can't really, it can't really hold the same amount of rich habitat value because it's missing so many different pieces. So what we want to do is we want to kind of bring that battery back up, because habitat degradation is one of the primary causes of species extinctions and loss of biodiversity. So habitat loss, fragmentation, as well as degradation are really important issues for us to address. But as we've learned, both from the introduction in my presentation and then in Paul's presentation, it takes a lot of time and effort to work on these types of projects, and there's a lot of management constraints. So these barriers include things like lack of time and resources. We're working on very large landscapes, and often if you're looking for small degraded sites or degraded sites within a large area of land, it's very difficult to do from the ground. And to compound that, there's few systematic reviews and tools available, published guidance to help land managers identify these degraded sites in these large landscapes at a specific point in time to help us provide that kind of management to prioritize where we're going to work on restoration projects. And so, you know, right here we have nearly 3 million acres of protected land. How do you find the sites that you want to restore within those areas? So for our approach, we have the citizen science restoration scanning approach. And as part of that, we really want this, it's a remote approach and it can be conducted over a relatively short period of time. We use multiple volunteers to do this, and it allows managers to undertake landscape level restoration prioritization and planning. So the idea is that this is a key tool for priority setting. We want managers to be able to look at the resources we provide from this method so that they can both identify critical habitat sites so that we can bring that from low battery back to high battery. And we want to provide key tools so that they can use that for restoration planning. So information on what native plants are typically in those areas, what soil type is typically on those degraded sites, and other important information like distance from trailheads to get there to do some restoration work and other factors related to that. So Dan's going to walk us through what our method is, what the citizen science restoration approach does.
Thanks, Mary. As Mary said, we developed this approach to try to address the issues that were facing land managers in trying to deal with this problem. And so we focused on using publicly available or common resources and processes and things that could be done quickly and with volunteers to identify relatively small degraded areas within very large landscapes. The approach has 4 phases. where the first phase uses volunteer teams and Google Earth to scan a landscape and do a preliminary identification. Then the second phase is a more detailed review of those preliminary results using high-resolution aerial photos and GIS software. Third phase is using the GIS software to produce some basic management information that will be helpful in prioritization. And then the fourth phase is addressing and providing some guidance about what kind of seed mixes and so forth might be useful for active restoration of degraded sites. Next slide. So let's use as our example the work that we actually did mapping degraded sites in the preserve in 2018. Now, of course, you're all aware that the preserve, although protected today, was subject to decades and in fact really centuries of previous degradation, including ranching, off-road vehicle use, camping, mining, etc. And today there is continuing use of this resource on all of our hundreds of miles of increasingly well-used trails. Now, the city of Scottsdale had noted potential restoration sites just from their routine work in the preserve. They had identified 41 degraded sites that were candidates for restoration. Next slide. We started phase one using Google Earth and multiple stewards scanning defined areas within the preserve on Google Earth. The reason that we used Google Earth was, first of all, it's free and anybody with an internet connection can use it. You can create polygons and points and lines on it. The things that you note on Google Earth can be transferred to GIS software. And very interestingly, in urban and near urban areas, the resolution of the satellite imagery provided by Google Earth is really extraordinarily good. It's much better than is typically available from free satellite software that you can get from NASA or other government agencies. So Google Earth is a wonderful place to start this process. We divided the preserve into 20 scan areas, and each of them was scanned by 2 volunteers working completely independently, not seeing each other's work. Next page. So we provided training to the volunteer team, including examples of distinguishing natural areas that didn't look great from actual degraded areas. But we did encourage the volunteers, the stewards, to mark areas whenever they were in doubt. We decided that we would much rather have false positives, in other words, sites marked as degraded that really weren't, rather than missing some potential degraded sites. In the first phase produced 376 potential degraded sites. The second scan transferred all of that information into the GIS software, where we were able to use high resolution aerial imagery provided by the city of Scottsdale that really can see individual plants and rocks down to about 4 inches in size. And this second round of review process using the high definition aerial photos allowed us to weed out a lot of the potential sites that had been identified. So the second round of review produced 75 sites. And then there was a final round of review with staff that came up with 67 potential restoration areas, all of which were new to the city of Scottsdale. In other words, they had not been previously identified. Next. The third phase involved taking those 67 sites and developing some information that land managers, city of Scottsdale in this case, could use to set priorities for approaching restoration. Things like how big is the degraded area? How far is that area from the nearest access point, such as a trailhead or a trail or a service road? And finally, what kind of degraded area is it? Is it an area, for example, that's still being used? Is it an area like a trail junction that's going to get bigger over time? Is it an old mining site and things like that? Next. And the fourth phase was trying to provide custom recommendations. Now, some sites can be restored passively simply by preventing further disturbance and let nature take its course. But other sites are so badly degraded that they need active restoration, including seeding, and it can be really difficult to figure out what's the right mix of seeds to use in a particular area. So the method takes advantage of USDA publicly available information called the Web Soil Survey that basically provides a list of plants that you would expect to grow naturally in each area. We put that layer of different soil types onto the map, and then we customize the plant list based on our flora survey of the preserve and other sources. Next. The result was a map which located the 67 new sites and gave characteristics of each of them. And these 67 sites ranged in size from about 50 square meters, not very big, up to more than 10,000 square meters, which is very big. And the total was 10.5 hectares, which is about 26 acres of degraded sites. Next.
Right. So
Mary, back to you.
Thanks, Dan. So we used this methodology remotely, and we knew that this process was cost effective. We were using free tools and having many hands make light work of the scanning process. So we knew it was useful to identify degraded sites, but we wanted to verify our results and compare those remote results to what we would find in the field. So we, in the fall of 2020, trained stewards to visit a subset of the 67 sites. And so we visited 22 of the degraded sites that were found remotely, and we went about verifying the remote process by looking at the area on the ground. We estimated the percent of plant cover that we were finding, but we made sure that we weren't including things on the ground that you wouldn't be able to see from satellite. And we also compared the description of disturbance type, and we took some photos as we were out there. So we compared those estimates and the cause of disturbance, and our result ended up being really positive for our remote process. So we found that all of the sites that we visited were in fact degraded. So there was no false positives. And we also found that the remotely sensed approach provided a better perspective of both the scale of the disturbance and the type of the disturbance. And you can kind of imagine that if you're on the ground, it might be difficult to see the entire spider trail network that goes through an area, rather than if you're looking at it by a satellite, being able to see the entire perspective, which really illustrates a distinct benefit of using this remote process for discovering and then being able to prioritize these degraded sites. And so the management implications for this is that this process has a lot of value. We know that this remote approach is a good way to identify degraded lands. We're very excited that this methodology is providing a new tool for land managers. We're able to find small to large degraded sites in large landscapes, which could be very challenging. If imagine trying to go into the preserve and map, 30,000 plus acres on the ground to see what's degraded. It would be very difficult. And so a great feature of this is that the scans are performed by citizen scientists with expert review, and we were able to use free information. And so where have we taken this? So we've taken this in a number of directions. We've now had a total of 67,000 acres scanned in the McDowell Sonoran Preserve, and we've moved into the 2 regional parks listed here, where we've also found quite a few number of degraded sites that were previously unidentified by the county. And so what we're doing next as our next steps, we've submitted a manuscript on this methodology to Restoration Ecology, which is in review, and we are working with the city of Scottsdale on a subset of the sites that were identified through this process, and also that they have identified as places for restoration planning, and we will be doing more mapping with the county. And so a huge thanks to all the citizen scientists who helped make this project possible, and to the city of Scottsdale, and more recently to Maricopa County Parks for working with us on this as well. Thank you. I don't know if we have time for questions because I heard the timer.
We've got time for maybe one. I haven't seen any pop into the chat. Okay, so we got a question that says, how well would this process work as a monitoring tool to track changes and disturbances?
Yeah, it's a really great point. We definitely addressed that in our methods paper, where we were saying, you know, if you looked at these same areas over time, you could try to monitor what's happening to the land remotely, but there are a couple factors that would have to come into play. You would have to have updated imagery and good quality imagery. So that would be a limiting factor, would be what imagery would be available.